Okay, today I'm going to show you how to start using Filecoin deal auctions to get your data stored on Filecoin. I'll walk you through a couple different pieces that you can use and how you'll set them up and what they're doing along the way. So the first thing that we probably want to do is just create some data that we aim to store. So for that, I'm going to pop over to PowerGate. You're not going to use the PowerGate system in any of this flow, but I will just use a tool that is part of the PowerGate CLI that you can use to prepare a car file. And the reason you might want to do that is if you have a folder of data that you're trying to create a car file for, and you want to be able to get the metadata for what's in that car file so that you can submit the correct deal. So I'm just going to go ahead and if I jump over to the Textile docs and the PowerGate section, there's this offline deals section. In there is this Filecoin batching information. So this just explains this offline deal preparation tool that's part of the PowerGate CLI. So like I said, I'm just going to run this so that I can take some data and turn it into a car file. I have some data in this critical data folder, so I'll just run this command and I'll give it an output of like that. So that should put right here in my downloads folder my critical data car file. So but you'll see what spits out of that is all of the metadata for creating a deal on Filecoin, and it includes my source file, this spelling bee champion video from NASA. So now that I have that data, I have everything that I need to submit a deal over the auction system. All right, so this is a little utility shell script that we make available to clients. All it's doing is wrapping a REST API, so it's nothing too complicated, but let's just use it to make it easy for ourselves. So if we go ahead and clone this and then jump into here, the final thing we need to do on Macs is on a Mac, you just need to make this an executable. So now we have this executable. Let's just do a dry run like that. And you can see that it spits out how we use this. And we'll need to give it an API. So that's where the auction metadata is sent. A token, this is what Textile provides clients. And then that metadata that we created for our upload. All right, so to create this command, Textile actually provides the first two pieces to every user. So here I'm providing an endpoint for auctions. You'll see this is running on Edge. So this is our environment for running tests. And since I'm just doing a demo, I'm going to use this. And I've created this fake token for now, but every client gets their own API token. So the next thing, actually, let's go back here, and so we know what we're filling out as we do it. So again, we're just going to run that, but now we need some more. We need some more information. So we'd need the car file URL, we'd need the payload CID, the piece size, the rep factor, all that metadata that we need. And so one important thing is that the car file needs to be in a place that's accessible for the storage provider to pull that data down. The car file that I just generated using the CLI, that's not accessible yet. I'd need to put that someplace. A lot of clients just run a little Nginx server on the same machine that then will give it an IP address where storage providers can pull from. I'm just going to skip that today and use a data set that I know is hosted already, that actually Web3 Storage provided us. And I'm just going to use that here because it's not really going to be stored again with any storage provider. It's just going to mock it for the case of the demo. So if I just drop that URL, if I just drop that metadata in for that car file, you'll see it has its own URL, and then it has its own PCID, payload CID, data size, and we're just going to give it a rep factor 1 here. And then I'm passing in two empty flags. You could leave these blank, but I'm just doing that to show you in the future. Here I'm not giving it a deadline or any list of providers. So I just fire that off, actually. What that's going to do is now that information has gone off to the auctioneer. It's being auctioned to all the connected storage providers. The winning auctioneer is being selected, and that data is being pulled by the winning miners. So what's really nice for a client at this point is that they don't even need a Filecoin wallet yet. And in fact, all of the Filecoin deal making is being done by the auctioneer on our machine. And so that means it's also using the auctioneer's datacap. So this is the easy path for starting to use this API. But obviously some clients want to use their own wallets. This could be because they want to use their own Filecoin balances, but because most of these deals are free right now, it's primarily driven out of wanting to use their own datacap. So clients that are wanting to use their own datacap, they're getting it applied to their own Filecoin addresses, and then they want to be able to sign these deals themselves. So for them, we have a slightly different approach to this, and I'll show you how it changes. So we'll come back to the broker in a moment, but we're going to jump over and grab another tool that we created for those types of users that want to sign their own deals. So for those users, we give them a different tool called the Go Auctions Client. Just means it was written in the Go language, so it's really just the auctions client. And so we give them the instructions on how to grab this. And right here in the README, there's really pretty solid instructions about how to install this and how to use it. So what we're going to do is actually run a stateful daemon. And so that means that this daemon is going to stay running. Unlike the shell script, when we run the shell script, it fires off the payload and it's done. And the client doesn't have to do anything after that. In this case, we're going to run this daemon, and it's going to keep running while we're making deals. And we'll come back to that in a little bit. But the reason that is that when you create a deal this way, you're going to kick off an auction. The winners are going to win, and then they're going to kick off the process of deal making. And only at that point will you get notified that you need to sign a deal proposal. So there's this gap between when you push the data, or when you push the metadata for creating an auction, versus when you need to sign it. And so this client handles that waiting, and it sits here and waits for that moment when it needs to sign deals. But it has some really nice little helpful tools that will help clients use this really easily. So here's the command to run the daemon. If they installed the daemon, it would be a little bit more simple, but here I'm running it from the source code. We give instructions on how to install it. Also, we can distribute pre-built versions of this for clients, but there's so few users right now, it's easier just to do it this way and walk them through. And then as we make the system more mature, we can distribute built versions. So here I'm just saying run this daemon. And I'm giving it 3 keys. This last key you don't really have to worry about. It's only because I'm running it on this edge network I mentioned before, so it needs to connect to some special things. So in production nobody would run that third one. But in the other cases, these are pretty nice. So the auth token, that is an auth to this daemon. So when you run it, you can run it and have other machines in your system connect to it. And only the ones that know this token would be able to push deals and get them signed here. So that's like for your own system security. If you're running this in some particular way, you could use that. The next one is we actually give it our wallet key. So if you do Lotus wallet export, you can get this private key for your wallet. And this doesn't leave your device. This is used by the daemon for creating signatures only. And so you'll keep it here in the daemon, but it's so that when that proposal request comes in, it signs it and it's off in less than a second. And there's no communication that has to happen with Lotus, no communication that has to happen with the network. So that means that a client can run this with their private keys and never have to run a Lotus node or any other node or long-term connection to the network. The daemon is just all they have to run. So let's go ahead and fire that up. All right, and it spits out some information that we're going to come back to, but the key things here are that it's connecting to the relay and that it's successfully connected. So we know that it's on the network now, and we're good to start using it. Now, to use it, actually, clients will run this exact same command that they ran before. So if you're a client, you can actually onboard, test this system, use our auctioneer to fire your first deals to the network. But then when you're ready, you can add a few more commands. So actually, let's go back to here in a second. I'm just going to quit that. If I run that, it gives you this information about what we're running, and you'll see the data in these last carets is actually the new information that we're going to give it. And what we're giving it here is we're actually telling it that we are running our own wallet, and this is how we should communicate with that wallet. So right, so we can run this exact same auction that we ran as a client before, and little mistake there. Okay, and now all we have to do is give it these three new parameters: peer ID, auth token, and wallet address. Well, each of those just come from this daemon that we fired up. So the peer ID is right here, so we give it that. And then the auth token, if you recall, that is our user provided token. So that's how it's gonna call this API. And the final thing it wanted was the wallet address. So this isn't the private key, this is just the public key for the wallet. So this is okay to go out to the network, and this is what is actually going to be communicated to storage providers. This is who the deal is coming from. So we give it that. So now, because it's got that information, it knows we're not creating deals from the auctioneer, we're creating deals from the local wallet, and have the local wallet do the signing. So it's really cool. If we fire this off, metadata is going to go to the auctioneer is going to auction it off, winners are going to be selected and notified, and then from those storage providers' own bid bots, these deals are going to kick off and come back. There we go. Okay, so that's off, and now we can jump back over here, and if we just wait, auction is happening, winners are being selected, and there's only one bid bot running on our little fake test network here, so I know who's going to win. And if we just wait a moment, we're going to see a little message come back saying that a deal proposal has been received, and our wallet here locally is going to countersign that and kick off the deal to the network. And there it is. So the deal proposal came in and it was executed successfully. And so that's it. So the single auction that we created is now off in the network. And you as a client can now go and keep running these. Go fire off as many auctions as you need, kind of measuring how well the network receives those. So we'll add more kind of back pressure management as we grow. But really the client can go and start firing off auctions and figuring out what the throughput is for them. But that's it. And with that, no communication to Lotus. They signed their own deals. They're using their own datacap, and they're just using this auction network. Once they've got all of their proposals signed, they can shut this down safely, and disconnect from auctions. And that's it. Hopefully that was helpful.